The design journey of the solar cell, enabled through technological advances between 1880 and 1940, aligns to the principles and timeline of the modernist era. Modernism rejected the historical use of ornate decoration, focusing instead on innovation with form, production, materials, and ideas. Rather than work conventionally with known materials and traditional techniques, emphasis was placed on new processes, materials, and aesthetic. The vision for a better post-war future was a utopian dream, that technological advances coupled with innovative design could improve the world for future generations. The solar cell evolved from ideation to experimentation to invention, following these principles, to become the variety of products available today. Harnessing the sun has long been a human aspiration. It is debated whether in 212 BC Archimedes built a death ray using the sun and mirrors to set fire to attacking Roman ships. The capture of sunlight to generate electricity, the photovoltaic effect, was discovered in 1839 by French physicist Alexandre Edmond Becquerel. In 1883, electrician Charles Fritz developed a primitive solar device, though how to use it was unclear, until in 1905 Albert Einstein defined how light carries energy which can be turned into power, winning a 1922 Nobel Prize in Physics for his papers on photoelectric effect and his theory of relativity. The first practical solar cell was built by a Bell Labs team in 1953, based on a design patented by engineer Russell Ohl in 1940, which had only 1% efficiency and was marketed as a solar battery.
Turning sunlight into electricity, scientists of the Bell Laboratories at Murray Hill, New Jersey demonstrate a solar battery which converts light into power. A small amount, yes, but a big first for science. It's a simple device made of strips of silicon, principal ingredients of ordinary beach sand. Enough light from a lamp to power this toy Ferris wheel. Lights on, she works. Lights off, the motor stops. The solar battery may lead to the realization of one of man's most cherished dreams, the harnessing of the almost limitless energy of the sun for man's use. Here, the silicon battery powers a tiny radio transmitter, which uses transistors in place of tubes. His voice is carried only a short distance, but larger batteries may someday power our homes. Lamplight from sunlight.
Due to costs, by 1956, research was primarily government funded for use on spacecraft, enabling participation in the global space race. Experimentation began with scale, form, and materials required to generate the most energy from solar and to find new ways to use it. Design overtook function. In the 1970s, Dr. Elliot Berman designed a solar module using less pure silicon, reducing the cost of wattage and making solar affordable for commercial and residential use. In the 1950s, the cost per watt to build solar panels was equivalent to $1,910. By 1977, the cost was $40, and today solar cells cost less than 74 US cents per watt. Solar cells were combined into panels, panels into arrays, into farms, many connected to the primary power grid. Solar panels were used in remote locations where utility grid connections were too expensive. Film-thin solar cells were developed in 1980 and were integrated into small electronics like calculators, watches, toys, and radios. Sun-tracking solar systems were developed using smaller concentrating cells that seek heat and reposition to directly face the sun as it moves across the sky. 40% of the world's total energy consumption comes from buildings. Integrating solar collection was enabled through new design: flexible solar shingles, solar skins that customize panels to look like any material, glass solar blocks, solar windows, and transparent solar concentrating skylights that store light not needed as energy. In the streets, space is utilized more effectively with solar tunnels, roads, sidewalks, driveways, and bike paths, changing how community energy can be generated. some integrating LED bulbs for night lighting or thermal heating to melt snow or ice in winter. Solar integrated textiles with sewn-in mini cells or spherical microcells that collect light from their entire spherical surface are making it possible to expand solar into products like curtains and upholstery. Other devices include the window socket, a portable solar collection and storage device, solar lamps, and solar-powered water purifiers like the Watley system piloted in Ghana, a machine that generates and stores electricity, purifies and desalinates water, and connects residents to the internet. The sun shines more energy to the Earth's surface every hour than the global population uses in a year. While global energy production doesn't yet meet consumer demands, innovation in solar power addressed this using new methods of distributing power. Traditionally, electricity is generated through burning coal, oil, and gas. Today, 2/3 of global electricity production come from fossil and nuclear fuels, with only 24% from renewable sources. In 2013, almost a quarter of humanity, 1.3 billion people, had no access to electricity. Global population in 2015 was 7.334 billion, and 1.1 billion still had no power, half located in Africa, where energy poverty is most apparent. Roadblocks to electrification are cost and access to the utility grid. Centralised power grids provide the broadest access for the lowest cost. Decline in the cost of solar products, energy-efficient appliances like LED lighting, and financing models based on mobile phone payments are making decentralised energy solutions more accessible. Decentralised solar solutions include microgrid projects, small-scale grids that can later integrate into main national grids, home solar kits, typically a single rooftop panel, energy storage battery, and several LED lights, which can power appliances like refrigerators, TVs, or computers, and Pico solar systems that for as little as $15 provide a low electrification through one solar panel and battery to power LED lamps and perhaps a mobile phone charging port. World wars have been fought for access and ownership of finite natural energy resources. Now, countries are competing to gain control over new energy markets, reducing influence of oil producers and enabling traditionally resource-poor countries to realise their opportunity to lead these markets. Internationally recognised basic human rights include the right to water, food, adequate housing, health, working for a living, and to participate in cultural life. Energy required to cook, heat the home, bring water to remote areas, access radio and communications, to power lights, appliances, and facilities like hospitals and schools is not considered a human right. 3 billion people worldwide use dirty fuels like wood, agricultural residues, dung, and coal to cook meals. Time spent collecting these fuels, typically a domestic activity of women and girls, limits time available for education or paid employment. Solar products cost less per day than kerosene, candles, and fossil fuel generators, providing opportunity for solar and hybrid electricity systems. Communities can utilise their land for farming solar energy, empowering them to join the economy. A household solar system provides light, enabling children to do homework at night, women to make time for employment and education, and in the dark of night to feel safe in their home. Martin, a farmer turned solar distributor in Africa, shares his vision for the future of solar energy.
If it does happen that we get to a point where every home has their own independent supply of energy, that will give us the democracy of energy. That's it. And everybody has that choice. That freedom getting back into the hands of the consumer, that will be the most exciting.
The solar cell has transformed how we power our society, evolving through the modernist principles of rejecting historical methods, experimentation with form, materials, and processes, and working optimistically towards a better future. Technological advances and innovative design continue to improve the world for future generations.